Alright, so this is the beginning of chapter 2, lesson 1. Now, we're going to be doing a lot of stuff that we did in last chapter, so all the end behavior stuff, the limits, the increasing, decreasing intervals, all that stuff is still here. It's not going away. Also, there will be a lot of algebra in this section, so if we have to, we can start doing reminding algebra lessons after school or something, because we're struggling with algebra skills pretty bad right now. But we'll figure it out. So here we go, chapter 2, lesson 1, and what we're going to be dealing today with is graphing and with graphs and analyzing functions. And what we're going to be looking at is the power functions, the functions with exponents. So what we're going to do to make this really easy, and I've said it several times in the class. So what we're going to do is look at monomial functions, so one-term functions. And so we're looking at f of x equals ax to the n. Well, this is your power function. So what we're going to do is we're going to look at this as n is a positive integer. So it can be 1, 2, 3, 4, 5, 6, 7, 8, and so on, but we're not going to have any negative exponents just for a little bit. Later in the video we will. So we're going to look at 4 things here. First thing we're going to do is we're going to look at if n is positive and the number in front is positive. So here we go. This is the generic thing. We're looking at even powers for n, even. And we're looking at is a is greater than 0. So it's going to look like a parabola. Y equals x squared, f of x equals x squared, f of x equals x to the 4th, f of x equals 1/2 x squared. We're looking at those positive numbers in the front and the even powers. So describe the graph. So here we go. It's a parabola and both of the ends will go up. So our domain is from negative infinity to infinity. It stretches. The range is from 0 and up. Okay? Now the intercepts of the graph is the origin. So your x-intercept is 0 and your y-intercept is 0. So 0, 0 is your point. A lot of you guys actually missed that on the test because you weren't telling me if it's your x-intercept or your y-intercept, or just even stating it was 0, 0. 0, 0 would have been an accurate answer. Now, is it continuous? Yeah, it's continuous for all real numbers of the domain. Is it symmetric? Yes, symmetric along the y-axis. So anything with an even root is symmetric to the y-axis, and if it's a monomial. Our minimum point is the origin. It's the lowest point. So, reminder, is that your absolute minimum or is that your relative minimum? It's your absolute minimum. So it's the lowest point there is on the graph. The intervals, decreasing and increasing. We're decreasing from negative infinity to 0. And then at 0, we're increasing again. That's why it's a minimum. We're decreasing and increasing. It's the point where we switch. And then our end behaviors. As I go to negative infinity, I'm going to positive infinity. So as the limit of f of x approaches negative infinity, it equals infinity. As I go to positive infinity, the graph is still going up. So as the limit of f of x approaches infinity, it is still infinity. So that is what it is for even roots and a is greater than 0. So now let's look at if a is less than 0. So now what we're looking at is if it's an even root and the a is less than 0. So basically if the a is a negative. We're looking at basically if it's f of x equals negative x squared, f of x equals negative 3x to the 4th, f of x equals negative 7x to the 100th, because 100's even. So what happens is, if a is less than 0, it's going down to negative infinity. So what describe the graph? Analyze the graph. Well, the domain is still negative infinity to infinity. It's going that way completely. The range changes. Earlier, when the parabola was facing up, it was going from 0 to infinity. But this time, it's going down. So our range is from negative infinity to 0. So remember, we go up, down to up. Our intercept's still the same. It's still 0, 0. Is it continuous? Well, yeah. There's no holes. There's no discontinuity. There's no vertical asymptotes or horizontal asymptotes or anything like that. Is it symmetric? Yes. To the y-axis. All even roots are symmetric to the y-axis as long as it's a monomial. The minimum, it's not a minimum this time. It's a maximum because it is the highest point. Now again, is it an absolute maximum or is it a relative maximum? Well, is the highest point, so it's absolute. It's an absolute maximum. This time, the interval's changed, okay? And that's why it's a maximum. It's increasing from negative infinity to 0, and then it's decreasing from 0 to infinity. That's actually the definition of a max. It's where the increase changes to decrease. And then the end behaviors. This time, as the limit as x approaches infinity, f of x equals negative infinity. So as I go to positive infinity, it's going negative infinity. This, as the limit of f of x as x approaches negative infinity, again, it is negative infinity. As I go this way, I am going down. So that's the end behaviors, and that's describing that graph. The easy way to remember even roots, and I said it several times in the class, is the even roots will either both of the end behaviors will either both be pointing up or they both will be pointing down. If it's positive, they point up. If it's negative, they point down. So that's the best way to remember that. So let's get into if it's not an even root, it's an odd root. So now we're in the even roots. So we're looking at even roots, and then we're looking at if a is positive. So what we're looking at is like f of x equals 3x to the third, f of x equals x to the fifth, f of x equals 1/2 x to the ninth. We're looking at even root or odd roots, and we're looking at if the a is greater than 0. So your graph this time is kind of the squiggly, kind of like the cubic function. Well, yeah, it's a cubic function, so it's squigglies. So what can we describe it? What can we analyze about the function? Well, the domain is all real numbers. It's from negative infinity to infinity. The range is from negative infinity to infinity. So that's pretty easy. Your intercept is still the same. It's still the origin. It's 0, 0. Is it continuous? Well, yes. There's no holes. There's no vertical asymptotes or anything like that. Is it symmetric? Well, odd roots are symmetric to the origin. So as long as it's a monomial. So remember, even roots are symmetric to the y-axis. Odd roots are symmetric to the origin as long as it's a monomial. Is there a max or a minimum? Well, no, because it just goes. Increasing. The intervals. It increases the entire time. It's increasing, increasing, increasing. Remember, increasing, we're looking at what's happening during the domain. And your end behaviors. As I approach negative infinity, I'm going to negative infinity. As I approach positive infinity, I'm going to positive infinity. So as the limit as x approaches negative infinity, f of x is negative infinity. The limit as x approaches infinity, f of x is infinity. So we're looking at all of these aspects. Again, so one more we're going to look at what happens is if the odd root in the a is a negative. Okay, so let's look at the odd roots as a is less than 0. So the ones we're looking at is if f of x equals negative 2x to the third, f of x equals negative 1/2 x to the fifth, f of x equals negative x to the 17th, anything that's odd. So what happened is the direction changed. Instead of, and I'll erase it, instead of going up, increasing, what's happening to the graph is it's decreasing the entire time. So if we analyze our function here, our domain is all real numbers and our range is all real numbers just like before. It's going left to right the entire time, and it's going down to up the entire time. Your intercepts still 0, 0, crosses the origin. Continuity, yes, it's still continuous. It's symmetric to the origin. Odd roots are symmetric to the origin as long as they're monomials. And maxima or mins or extrema stuff, there's no extremas. Instead of increasing when it's positive, it's decreasing when it's negative. Kind of common sense there. It is going down. So remember, intervals are based on the domain. So as negative infinity to infinity is happening, the graph is decreasing. And the last thing is your end behaviors. As I approach negative infinity, it's going to infinity. As I approach positive infinity, it's going to negative infinity. So the limit as x approaches negative infinity, f of x is infinity. The limit as x approaches infinity, f of x is negative infinity. So let's actually do a couple problems, and hopefully this will make a little bit of sense.